Hello everyone, welcome back to video. Today we are going to discuss about the topic combinational circuits. Let's get into the topic. Introduction to combinational circuits. Combinational circuits are digital circuits where the output at any time depends only on the present combination of inputs. These circuits have no memory element, meaning the output is solely determined by the current input values. Combinational circuits are fundamental building blocks in digital electronics. Basic building blocks of combinational circuits. The basic building blocks of combinational circuits include logic gates such as AND, OR, NOT, NAND, NOR, and XOR gates. These logic gates are combined to perform various logical functions. Combinational circuits do not have any storage elements and respond instantly to input changes. Truth tables are used to define the output of a combinational circuit for every possible input combination. The truth table lists all possible inputs along with the corresponding outputs. Truth tables help in understanding the behavior of the combinational circuits. Designing combinational circuits. The design process of combinational circuits involves specifying the required logic function through a truth table or Boolean expressions. The logic function is then implemented using the appropriate combination of logic gates. Designing combinational circuits requires a good understanding of Boolean algebra and the logic gates. Applications of combinational circuits. Combinational circuits are used in various applications such as arithmetic circuits, multiplexers, demultiplexers, encoders, decoders, and more. They are essential in digital systems for processing data and making decisions based on input conditions. Combinational circuits play a crucial role in the operation of computers and other digital devices. Half-adder circuit. A half-adder circuit is a basic combinational circuit that adds two single-bit binary numbers. It has two inputs, A and B, and two outputs, the sum and the carry. The half-adder circuit does not consider any carry from the previous stages. Full adder. A full adder is a combinational circuit that adds two single-bit binary numbers along with the carry input. It has three inputs A, B and the carry input C in and two outputs, the sum and the carry output, that is C out. The full adder circuit considers the carry from previous stages, making it suitable for adding multiple bits. Multiplexer circuit, which is also known as MUX. A multiplexer is a combinational circuit that selects one of the input data lines and forwards it to the output based on the select lines. It is often referred to as the data selector. Multiplexers are widely used in data routing and communication systems. Demultiplexer, which is also known as DMUX. A demultiplexer is the opposite of a multiplexer, where it takes a single input and selects one of the output lines based on the control signals. Demultiplexers are used for data distribution and routing. They are commonly found in communication systems and memory devices. Encoder circuit. An encoder is a combinational circuit that converts a set of single signals into a coded output representation. Encoders are used in digital communication systems, data transmission, and error detection. They help in reducing the number of input lines required to represent a set of data. Decoder circuit. A decoder is a combinational circuit that performs the opposite function of an encoder, where it converts coded inputs into a set of output signals. Decoders are essential in digital systems for address decoding, data routing, and control signal generation. They are commonly used in memory systems and digital displays devices. Comparator circuit. A comparator circuit is a combinational circuit that compares two binary numbers and generate output signals based on the relationship between the inputs. It determines whether one number is greater than, less than, or equal to other number. Comparators are used in arithmetic operations, control systems, and decision-making circuits. Arithmetic logical unit, which is also known as ALU. An arithmetic logic unit is a combinational circuit that performs arithmetic and logical operations on binary numbers. ALUs are a key component of central processing units, which is CPUs in computers. They can perform operations such as addition, subtraction, and or and shift operations. Code converters. Code converters are combinational circuits that convert one type of code into another, such as binary to gray code or BCD to XS3 code. These converters are used in digital systems for data conversion and compatibility. Code converters help in interfacing different systems with varying code formats. Parity generator and checker. Parity generators are combinational circuits that add a parity bit to a data stream for error detection. Parity checkers are used to verify the integrity of the data by comparing the received parity bit with the generated parity bit. Parity generation and checking are essential in communication systems to ensure data accuracy. Priority encoder. A priority encoder is a combinational circuit that encodes multiple inputs based on their priority level. It generates a binary code representation, the highest priority active input. Priority encoders are used in interrupt systems, task scheduling, and control applications. Troubleshooting combinational circuits. Troubleshooting combinational circuits involve checking the input signals, verifying the connections, and analyzing the outputs. Tools such as logic analyzers, oscilloscopes, and circuit simulators are used for troubleshooting digital circuits. Understanding the circuit design and logical behavior is crucial for effective troubleshooting. Advantages of combinational circuits. Combinational circuits are simpler in design compared to sequential circuits, making them easier to analyze and implement. They have faster response times since the output depends on the current input values. Combinational circuits are well suited for applications where immediate outputs are required without the need for memory elements. Limitations of combinational circuits. Combinational circuits cannot store any past information, limiting their ability to perform tasks that require memory or sequential logic. They are not suitable for applications that involve feedback or iterative processes. Complex operations that require stateful behavior are better implemented using sequential circuits. Conclusion. Combinational circuits are essential components in digital electronics for performing logical and arithmetic operations. They consist of basic building blocks such as logic gates, multiplexers, decoders, and encoders. Understanding the design principles and applications of combinational circuits is crucial for developing efficient digital systems. Thank you for watching.